Assalamualaikum and hi to everyone. My name is NURUL NAJWA binti Muhammad RIZAL from Group J. So today I want to present about introduction to Mips assembly language programming. The Mips assembly language is based on the RISC, which is Reduced Instruction Set Computer Architecture. Refers to the Mips processor assembly language. Mips is an abbreviation that stands for Minimum Information Processing Standard. It is a simplified instruction set that is established by an organization, and it is a microprocessor without interlocked pipeline stages. Mips technology is the name of the company. R2000 was the first commercial Mips model. There were 32-bit general-purpose registers in it. Next, there are a few advantages of assembly language. First, how applications interact with the operating system, CPU and BIOS. Second, how data is represented in memory and other external devices. Third, the processor's access to and execution of instructions. Fourth, how data is accessed and processed by instruction. And lastly, the method, which is a program connects to an external device.
Hi, I'm SYAHMI. So here I represent the coding. Firstly, here we have lines of comments, which we have the list of our group members and our group. So firstly, in the data section, we have the array1, the word as the array, and then we use the .skeys to store the string in the memory, and then .space to allocate spaces for the wording and word. So we go next to the .text section. In main function, we first prompt for title. So we load immediate v0 equals to 4 to display string, and then we load address the title into a0, and then syscall to display it. Next, we load immediate t1 equals to 255 for validation later, and then we set up the loop variable. We load immediate t0 equals to 10 as the loop counter, and then we load address array1 into the S1. Okay, in the get input function, firstly we prompt for input, so we load immediate v0 equals to 4 to display string, and then we load address from 1, which will display the enter integer numbers 0 to 255, and this is called to display. Next, we read the input, so the immediate v0 equals to 5 to read the input, to read the word or integer, and then syscall. Then we go to check input. In the check input function, we firstly set less than immediate. So if the value entered is less than 0, then the S2 will be 1. If it's true, it will be 1. If it's not true, it will be 0. So next we set less than t1, which is 255, and then the value. So if the 255 is less than the value, or the value is bigger than 255, then it is true. So the S3 will be 1. It's not true, and the S3 will be 0. So here we use the bitwise operator OR. So we check S3 and S2. So if either one is 1, then S4 will become 1. So if S4 is 1, so we will go to invalid. In the invalid function, we firstly display the validation. So the V0 to 4 to display string, and then the address validation. You will display the invalid integer, enter again 0 to 5 to 55 only. So Cisco to display it. And then we get another input. So V0 to 5 to read the input, and then we go to check input. So we go again. If the S4 is 0, means both are false, and then we store it in the S1, which we load as the array1 address. So we start with 0 as the first input, and then we print the separator line, which here you can see this line here. Do not get confused later. And then we decrement the loop counter and continue. So first we sub the T0 by 1 or add -1 into T0. So it will be the loop 10 times, and then we add S1 by 4 to go to the next pointer for input in S1. So if T0 is greater than 0, so we'll go to get input, we'll loop, and then if T0 is equal to 0, we'll go to display setup. Okay, after 10 input, we'll go to the display setup. The display setup, we just set the T0 again as the S10 as the loop counter, and then we load address array1 into the S1. So now we will display the number in the display function. So we load immediate V0 to 4 to display string, and then we load from to address into A0. So it will display the integer is, so Cisco to display it, and then we print out the integers. So we load V0 to equals to 1, we display the integer of word, and then we load word A0 from the array1 from the S1. So Cisco to display the input. We will go to binary. For the binary part, we have three functions: the bin function, the loop following function, and the function. Firstly, we load V0, the immediate V0 to 4 to call string, and then we load address from 3 into A0. So the from 3 will display the value in binary is, then use Cisco to display it. Next, we will load the input into T2 from the array S1. Next, we clear out the T5, we initialize as 0, and then we initialize T3 S1 as a mask, and then we shift left the mask by 7 to the left. So let's see, we get the 0, 0, 1 as T3, and then we will shift the T3 by 7. So 1, 2, 3, 4, 5, 6, 7. So the mask will be here. And then we load T4 as the loop counter. So we need the loop to go 8 times. Then we set the T4 to 8. So in the loop following function, we take the input 10 as example. So we have T3 this, and then we'll have the example input as 10. So 10 in binary is 100. So we end the T2 and the T3 into T5. here we end, and then the result will get. The AND is the bitwise operator, and so it will check if the T2 has 1 and the T3 has 1, so it will become 1. If not, it will become 0. So if the T5 is equal to 0, like this, then go to print. In the print function, we load immediate v0 to 1 to call the integer over, and then we move the T5 0 here into A0 to print it. So here it will show 0. And then we shift right logical the T3 by 1. So we move position to here. Then we will sub the loop by 1, so it will become 7. So if the T4 is not equal to 0, so it will look to the loop for bin. Then we will check. So if 0, it will print 0. It will print 0. It will print 0. And then the bus is already here. So the result will be 1000. So if the result is not 0, then we clear out T5, then we set T5 as 1, and then we go to print. So you will print 1 here. The same thing will be if the mark is here. After the 6 load, so it will become 1010. So we'll go to alternates.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad ADLI bin MAZLAN, and I'll be presenting decimal to octal. So we have prim from 4. First we are going to look at V04. So here we are going to load return value V04 to call string. Then we have A0 from 4 to display from 4. Then we have initialize values for the inner loop. First we have T3 word, because we want to load address T3 equal to word. Like we mentioned in the beginning coding, word equal to dot space 12, because we want only 3 place for the display. Second we have T7 0 multiply 07 for the mask value. Then T4 6, because we want to load T4 equal to 6. And T5 3 we are going to use for loop for awk, counter and shift amount. For the loop for awk, first we need to shift right T4 first. So here T4 is equal to 6. Then we have N, because we want to combine T6 with T7. Next, load byte, because we want to checking the value with the odd digit. Next we have store byte. If the value less than 7, then it will store into T3. Then we need then we have to subtract T4 with T5. Next, if T4 more than equal 0, it will go to the loop for awk again. That's it. So let's continue with decimal to hexadecimal. So for the print prompt, it is same like the octal. So we are going to initialize values for the inner loop. First, we are going to load T6 equal to hex digit, and T7 is going to load wording. And wording as we mentioned in the beginning coding, wording equal to dot space 8 because we only want to place for the display. Then we load T3 equal to 15 as mask value. Next, we are going to shift left T3 by 4 bit, and T4 and T44 we use for look for heads counter and shift amount for T5. Then we initialize T5 equal to 0. For look for heads, first we are going to check the value of T2 and T3 for value T5. Then we shift right T5 by T4 bit, which is 4 bit. To get the proper hex digit, we check the value with the hex digit. Then we transfer T5 into T8, and then store T8 into T7. For process loop values and branch, first we shift right T3 by 4 bit, then T7 plus 1 and T4 minus 4. So at the process initialize values T4, we minus with 4 2. Then we get the value is 0. And then if T4 equal to 0, it will go to look for hex again. Next, we are going to print hexadecimal value. So we call we load return value v0 equal 4 to call string, and load a0 equal wording to display wording. Next, we are going to print new line. So we load return value v0 equal 11 to call ASCII character, and a0 10 to load as ASCII value of new line is 10. So next, we are going to print separator line. First, we are going to load return value v0 equal 4 to call string, and then we are going to load a0 equals line to display line. Then for display decrement, the process loop values and branch. First, we are going to add T0 with minus 1 for decrement for loop counter, and we add S1 with 4 to go to the next input. And then if T0 more than 0, it will go to display. Then for termination, we are going to load return value v0 equal to 10 to terminate the program.
Hello, my name is NURUL binti HARUL AZMAN. I will present for the sample output. As you can see in the results, each number is represented in their own space and be divided. This way, user can see and find the answer easily. User can just look the integer they write, for like example number 15, and find the 15 in binary is 00001111, and for the octal will be 017, and lastly for the hexadecimal will be 0F. But if you put less than 0 or more than 255, the result will be invalid. Will continue to show invalid until the user re-enter the integer within the range of 0 until 255. You can see the result here. In this demo, I will show how the code works. As I said, user can only put any 10 random number that is within the range of 0 until 255. But if the user put, for example, -1 or -99, it will show to be invalid, and you have to re-enter the number only within the range provided, which is 0 until 255. Same goes if you put more than 255, like 469 or 999.